So now we're going to look at a different library, the I2C library. Actually, it's called the Wire library, but it supports what's called I2C communication. So one of the things that you often want to do in a system, when you have a microcontroller, you want to connect it to another integrated circuit, some other chip, right? Maybe it's a memory chip, maybe it's a digital analog converter, whatever it is, right? You want to connect your microcontroller to other chips so you can talk to those chips and tell them what to do, grab data from them, and so forth. So these chips, when they communicate, there are several different protocols, communication protocols, which they can use. The one we're going to talk about right here is called I2C. I2C communication protocol is a serial protocol, and it's a synchronous protocol. So serial means it sends data over only one wire. Data is only traveling over one wire. This is good. Serial protocols are good because they save bits. They save pins, rather, right? You don't need many pins. You just need the one, or in this case, you need two total pins, but data is only going across one. So you need very few pins. The downside of that is that since it's serial, it's sending one bit at a time. So it takes longer. It's slower. If you send 8 bits in parallel, that's a lot quicker than sending one at a time. So it's a serial protocol, which saves pins, which are important. Also, it's a synchronous protocol. What that means is that if there are two communicating entities, two integrated circuits, talking about I2C, they need to share the same clock. So they need to get the same clock. They need to share it so that they can synchronize with each other. So based on the clock, the receiver knows when the sender is going to be sending data, right? So they need to share the same clock so they can be timed correctly. So the receiver knows when to read the bus, and the sender knows when to write. So it's a synchronous protocol. It's a serial protocol. Multiple masters and multiple slaves. So we're going to talk about this concept of master and slave. But basically, the master is the one who starts all the communications, and the slave is the one who waits for communications, roughly. And you can have multiple masters and multiple slaves in this particular bus protocol. Bit width is fixed. So when I say bit width is fixed, the number of bits traveling between these two, between any number of devices on an I2C bus is fixed. It's always 2. There's the data signal and the clock signal, just 2. And it's independent of the number of slaves. There are other protocols where every slave you have to add more bits. But I2C, you can have as many slaves as you want, or up to the limit that they enforce. And and it's the same number of bits, 2 bits. So 2 wires, SDA and SCL. These are the common names. SDA is the data. That's the line where the data is going to travel. And SCL is the clock that's used to synchronize all the devices. Both lines, SDA and SCL, are open drain. So what that means is that they are connected to power through a big resistor. And so what happens is they're pulled up high by default. That means if, let's say there are lots of different I2C communicating entities on this bus, they're wired to the SDA and SCL lines, but nobody is talking on the bus. So none of these components are driving those 2 wires high or low. Because they're connected to power through a big resistor, they will automatically go high. They will be high. Now, if any one of these communicating entities want to force a 0 onto the line, they can. They can pull it down to a 0 because it's a very big resistor, so it's a weak pull-up. So you can pull it down, but if nobody is talking on the bus, the state of the bus is still defined. You always know that it's going to be high by default. And that's actually useful in the protocol to know that the state is always either 0 or 1. It's not some random intermediate value. So some of the terms that we're going to need talking about this bus protocol. One is the master and the slave. So a master is a node on the bus that initiates and terminates transmission. Okay? So the transmission, when transmission starts, the master starts it. When it stops, the master stops it. Also, it generates the clock, SCL. So the clock is generated by the master. Now, the slave is addressed by the master. So the slave basically waits until the master starts communication and until the master stops communication and does whatever the master says. So these transmissions are either write transmissions or read, sending to or from. And the slave just essentially obeys the master. If the master says, I'm doing a write, then the slave knows, okay, I better listen. I better read. Right? I better read whatever's on the bus, and so forth. So there's master and there's slave. Now, in addition to that, there's also transmitter and receiver, which are orthogonal to master and slave. So the transmitter is whatever node is putting data onto the bus. And the receiver is whatever node is receiving data from the bus. Now, the master can be the transmitter. It can be the master that starts the transmission and puts data on the bus because they're doing a write. They want to send data to the slave. But the master can be the receiver. The master can start a transmission and say, okay, slave, this is a read transmission. So it effectively orders the slave to give it information. So the master can also be the receiver. And the slave can be the transmitter or receiver also. So every node is either a master or slave and can also be either a receiver or a transmitter. And they can be mixed and matched. So master can be transmitter or receiver. Slave can also be transmitter or receiver. This is a picture of what the bus network will typically look like. Each one of those blue boxes labeled master slave. Think of that as probably an integrated circuit or some component that is talking on this bus. And they're labeled master and slave to say what their roles are on the bus. And there are a couple of masters and 3 slaves. You can mix and match. Each one of them is connected to the same set of 2 lines, SDA and SCL. So SDA and SCL are common to all the masters and slaves, all the nodes on the bus. And they share them. And they're bidirectional, so you can talk in 2 directions. Data can go either way along those wires, from left to right, right to left, whatever. Also notice that the 2 lines, SDA and SCL, are wired to VCC, meaning power, through big resistors. Those resistors aren't labeled, but they are presumably big, 10K ohms or something like that. So this is what the typical I2C networks looks like. We'll be talking about networks with just 2 nodes, 1 master, 1 slave, but you can have much larger networks like the one we're seeing here. Thank you.